invited to an interview if you are like suitable. And in this interview, it's a short one. You record it online by yourself, and it will ask you some questions about why you want to do civil engineering. And there'll be some technical questions. So they'll give you like a problem and they'll ask you to explain the physics behind it. One piece of advice I have for you for your UCAS application is that because I know that your personal statement or these new questions that you have, there's a limited number of characters. And if you're somebody that does a lot of stuff outside, there might not be a lot of space for you to talk about it. So try and get your teacher on board with some of the stuff that you do outside of your school time, and maybe they can include it in their reference so it becomes like a second personal statement. And universities really like that. And finally, for the grade boundaries, usually it's A star, A star, A, or A star, triple A. And if you're doing the three A levels, you need the A star in maths and physics. But like from experience, sometimes if you get below A star, A, or below this, they can consider you based on the amount of spaces. So don't think that just because you didn't get it, you might not get a space. Okay, on to the course overview. So the essential modules of civil engineering, so you'll cover these modules in year one, year two, and year three, are soil mechanics, structural engineering, and fluid mechanics. Those are the main three. In years one and two, you're going to study maths. So it's just going to be pure maths like you're used to at A level, but just an extension. So maybe an extension for further maths and onwards. Don't worry if you don't do further maths because it's not a requirement. But if you do, it's a bonus. But they make sure that you like get back up to speed with everybody. There's also a in like a module you can get into. It's required in year one and two. It's called environmental and energy, and that basically looks at like organic chemistry and microbiology and the link to like renewable energies and technology and like looking after the environment. And that's something you can take on in the elective modules in year three and year four. And another area of research you can go on to do in year three and year four are like structural engineering, or close, it has links to like mechanical engineering, where you look at dynamic systems like damping systems, or even if you like want to get really niche, you can look into like prosthetic limbs and like the structural engineering within that. And here some of these pictures are from the course I've taken. This bottom picture down in the corner, that's a soil mechanics lab looking at like the flow of water throughout like sand. Above that, this is the basic finite element analysis of a pylon, an energy pylon, which you do in year two, and that's pretty cool. And an extension of this finite element analysis, this is the basic one. Once you like go into year three and they teach you the like actual software, you use it to make that beam at the top with the green, blue, and the red colors. And in year one, you do a lot of design projects. We made like this little dome here. And one thing to add is that the way that you're assessed is through exams, projects, labs, presentations, report. And if you're afraid of exams, maybe this course isn't for you, because in year one, you've got loads of exams throughout the year. Your final exam, you've got eight of them. In year two, you've got one in January, five in May. Then in year three, you got five in January, five in May, and year four, five in January. And the nice thing about it, in year four, your final term is going to be a project. You choose a professor based on a industry you want to get into or area of research, and you just like make a project. That's your master's year. Okay, and the uniqueness about the course. So I'd say that this course is a very broad course. So there's like many topics ranging from like biology, chemistry. If you like that sort of stuff and you want to link it to like the environmental aspect, because this course actually is civil and environmental engineering. And there's also like loads of things to choose from. We also have a very active society, the Civil Engineering Society, which you can like search about. But essentially, what they do is that they organize talks with employers. They have a lot of careers fairs with like top employers, which can actually streamline you places for like internships and graduate roles. And each year they take us on trips to Europe so we can see like the civil engineering there. So last year we went to Istanbul as part of this trip. It was during like the Easter holiday, the first week of Easter holiday. So it was like during Ramadan. So it was a really nice trip because like We got to experience like the Islamic culture there. Obviously, that wasn't the purpose of the trip, but it was nice. And they took us to this site here. If you look at this picture and you see the tunnels, the bottom picture and the second picture from the top, we went to a construction site where they were building the new underground systems. And this is like an area of personally my interest is tunneling. And there's many professors that have worked on like some of the major projects around the world, such as like the London Underground tube systems and so on. And they have links to industry. And what you can do is if you're interested in a topic, you can reach out to like a professor and ask them to do an undergraduate research placement throughout the summer based on your area of interest. And another thing about this course is that you're going to spend a lot of time on residentials. In year one, you're going to go on a residential to Windsor, where you're going to look at like map drawing. So you're going to go out into the field, you're going to have the equipment, and you're going to measure like the heights of the land, and you're going to create like contour plots of the area. And that's really fun. Year two, you're going to go off to Wales to go and look at like rocks in like by the beach. So that's nice. And you're gonna go on in year two as well to Norwich. And in that trip, you're gonna construct something at a 1 to 30 scale. So it could be like a dam, it could be a bridge, but you're gonna be working on an actual construction site with like all the concrete, the rebar, all of that stuff. And another nice thing about the course is that we have a lot of labs. If you see at the top, that's our structures lab. It's very big and it's like in the center of like the whole department. And this third picture here is our hydrodynamics lab. So we can have like we have a big wave simulator and we've got like little flumes as well, which you're going to use in year one. And we also got some like geotechnical labs and an environmental labs for organize for like analyzing microorganisms. But we use that one less unless you were to go into the specifics in like year three or year four.
Jazakallah Ibrahim. Now we're going to move on to design engineering by Tahmid.
Assalamu alaikum, everyone. I'm Tahmid, and I'm studying design engineering at Imperial. Yeah, so I feel like a lot of you guys don't know what design engineering even is. So the official definition by Imperial is that it's the fusion of design thinking and engineering knowledge and practice within a culture of innovation and enterprise. So it is basically combining engineering with design thinking, and you get to learn a lot of design thinking skills all throughout your years. Yeah, so the application process is just sitting the ETA admission exams in maths 1 and 2 in either October or January, and these are just 27 multiple choice questions that you get 40 minutes to sit. My advice for that is to just revise for those thoroughly right before the exams. If you're shortlisted, you'll be invited to an online interview in either November to March. And this one you need to prepare quite a bit because it'll be like a about 10-minute interview and you have like 2 minutes to present a portfolio. So anything you've done in the past, you can just put into that portfolio just to present. And you also need A with an A in math. So I feel like it is one of the most more easier to get into degrees at Imperial. Yeah, so design engineering is a very multidisciplinary degree. It combines engineering, design, and enterprise skills. There's quite a few modules you learn. In first year, you'll have a lot of the foundation engineering modules that you need to learn, such as mechanics, electronics, computing, all the mathematics you need to know. And then from second to third year, you go more depth into certain modules such as mechatronics, robotics, design thinking, human-centered design, advanced engineering tools, optimization, and you also have uh, an enterprise and entrepreneurship module in year three, which you will actually have to start a startup. So you get the whole process of building a startup from scratch, which I think is a very good module. Yes, and the main methods of assessment is exams, group, and individual projects, presentation reports, and design challenges. So there's a fair mix of those. In the next few slides, I'll go into more depth into that. But just to show you around here, I've got a couple examples of what I've done this year. So you gotta be really good at sketching for this degree. So I'm not really that good at sketching, but I've learned from my first year on how to sketch. They'll teach you really nicely how to like portray your ideas. Because that's one of the main things of engineering is to portray your ideas so you can model them, right? So one of my modules was to create a car and then do the finite element analysis on those and just do a lot of analysis on that model, right? And I've got a bunch of those down there. And then as you can see, yeah, we can move on to the next slide. Yeah, so these are a couple of examples, not from me, but from other students past years for the second year module, the second year industrial design engineering module, where you have to make like a proper industrial device from scratch, right? And as you can see, it is quite complex. You need to go really in depth into what you're making. Yeah, you can just have a look at that. Okay, so yeah. Okay, so uniqueness about the course. One of the main unique things about this is that the balance of assessment is very coursework and project heavy. So when you get to like year 3 and year 4, 90% of the year 3 is basically coursework and practical. So in terms of exams, you won't do that many. In year 1, you do half of these exams, but after that, there's not many exams. So that's one of the most unique things about this. And yeah, exams are done throughout the summer. So I mean, not throughout the exams are done throughout the year. So instead of doing every single exam in the summer, you do a couple in like January, couple in April, and then a couple in summer. So it's very spaced out. So I feel like I quite like that as well because you don't have to like cram everything in towards the end of the year. Yeah, so and it also the module I was talking about, the innovation entrepreneurship module in year 3, where you basically start to make a startup. You learn everything how to make startup from the scratch. So all the thinking behind it, all the process that you need to do, they'll teach you all of that. And yeah, I think it's a really good module. Yeah. Yeah. Another very unique thing about the course is that we got to do everyone has to do a 6-month industrial placement in year 3, starting from April, I'm pretty sure, to September. So yeah, 6-month industrial placement, and these are a couple of the companies that some past students have gone into. So you can see quite big, quite well-established companies down here: Amazon, Apple, Rion Labs, Dyson, Striker. So that's one you get a lot of industry experience as well with this degree. Yeah, that's all from me.
Jazakallah Tahmid. Now we're going to move on to aeronautical engineering by Faaris.
Assalamu alaikum, guys. I'm Faaris. I'm a second year aeronautical engineering student, and I'm going to be telling you about why you should want to study engineering, especially aeronautical, and how to get in. So, to start with, Imperial Aero is the only course in the UK with an average 4A-star offer. I was one of those unlucky people to get that offer. However, that doesn't mean if you don't get that offer that you're not going to get in. So, I know people that got 2A stars and 2As to get in. So, it's not completely over. Uh, in terms of entrance exam, it's purely maths-based entry, where you need to have a strong understanding of maths and further maths. You need to have the understanding rather than just practice, because that's what the exam really tests you on. For example, in my MAT that I had, it was 30 questions. I only answered 8 of them, but I still got in. So that tells you it's about the quality of your understanding. Your personal statement must be filled with aero specific content, and I'm going to move on to that in a second. Most importantly, before you apply, you need to have a real passion for aero specifically, or it isn't worth the psychological damage. I've seen this a lot in my course, and I say this because this content will become your life a lot of the time. And at the top, you can see some of my boys sleeping in lecture, just to show you that it doesn't matter. Everyone in this course is still a real person. They're not all insane geniuses. It's a normal people who get in. Next slide. And so I'm going to show you now a good enough personal statement. This was my one, and so it's good enough because it got in. I want you to focus on those three words at the top, EAT, and don't focus too much on the words itself, but just how I distribute everything in the personal statement, where most of it focuses on action. This is because Imperial aero lecturers and admissions officers are looking for people that have initiative to do things. So where you choose, you eliminate, you simulate, you design, analyze. These are the skills that they're looking for. In your personal statement, you want to put all the focus on things that can't be shown in your A levels. So just take a second to look at that, and then we'll move on. And now for a course overview. So we were told on the first day, by the end, you'll have the tools to build a plane. And I'm in second year now. It's not completely there, but I can see how it would work. So the modules we'll take, I'll just list off a load of them now. We study aerodynamics, computing, numerical methods, engineering practice, materials, maths, structures, thermodynamics, flight dynamics, mechatronics, and propulsion and turbo machinery. That's just a load of words. I'm going to focus on the main few that you're really going to need, where, for example, maths is integral to this engineering course, where you start with learning about matrix manipulation and equations. Then you learn how to solve every differential equation type using matrices, for example. You move on to learning about signals and systems, how they work in machinery, and finally, modeling shapes and force fields, which is useful, for example, when you're modeling a flow around aerofoil. Moving on to aerodynamics, where you model how real-life fluid flows. So you'll start with modeling ideal flows around vortices and sinks, for example. You then solve for lift and drag around the body. Then you'll start going into compressible aerodynamics, where you need to understand how air flows through a nozzle. And then you move on to the hardest bit, shock waves, which is the real part of aeronautical engineering, which we struggle with. Structures, another really integral part of your course, where you're going to learn how beams bend. You're going to learn how much force it takes to crumple, as in buckle a rod, how much force it takes to snap it apart, and then you join it all together in complex pin jointing structures. And computing, everything in this course uses computing. You need to be as good at MATLAB as you are at Microsoft Word. So it starts from complete scratch, but you move on from MATLAB to learning how to work Python, to learning how to use C++. And these are especially integral in the projects that we're going to do, which involve solving numerical methods using these codes. And finally, engineering practice, which is the fun bit for me, where in first year you build your own turbine, then in second year you build a drone, and finally you design a plane completely from scratch in third and fourth year. And the weighting distribution over the years is in the first year 7.5%, second year 20, then 36, fourth year is the biggest, 36.5%. It's a 4-year course, and it just shows most of your marks will come from the end of it. But that doesn't mean bake off during the first 2 years, because you need to pass everything to continue through the course. And you'll see a picture on the right there, me and my boy, with a wind turbine blade that we made. I included that because although, yes, the course is very content heavy and it seems like you're just writing and solving equations, it is nice sometimes in this course to see your learning be built, having something tangible to make at the end of all this learning process. Moving on. So now here's examples of some of the questions that you're going to get in exams. So these are, on the left is a structures question, at the bottom is a flight dynamics question, and on the right is intro to aeronautics. These are questions I had to solve in my exams, so just take a second to look at the style. Most importantly, what you'll notice about these questions is that they're really unique. There's no textbook or set content specification set by Imperial Aero. It's all about how much research and knowledge you do. So you need to, every single word matters in these questions, and you need to be able to understand fully. It doesn't matter how many practice questions you do if you don't fully understand the content and the theory. And now I'm going to look at the main projects. So here are the main projects you'll work on, and it is at the very top is a lab report. These involve doing a lab for 2 hours and then there's spending 200 hours documenting, processing, and writing about it. On the left is my lab logbook. you're going to spend a lot of time on that as well, where you have to write everything about your logbook, about practicals that you do, your understanding of them, what you take from them, and designing your own practicals. In the middle is one of the pages from my aerodynamics exam this year. And what this shows is there's no set method to Imperial aero exams. You just have to kind of play around with what you know until something fits. Then next to that is my wind turbine blade, and that is probably the proudest thing that I've made at this point. That's the nicest part of aero, I'd say, just the ability to build. You always get the opportunity. And then finally on the right is C++ code that I made, which uses, which basically models a floating buoyant object in water. And I never came into uni with any coding knowledge. So to have learned this in just 2 years is really amazing for me. And then finally, what makes Imperial Aero unique? So to state it simply, everyone is genuinely unique around you. You know, one day off and you will feel behind, but that's okay. It happens. So the most important thing about the course is the people in your class. To stay alive, you'll need to work with your course mates because, as I said, there's no set textbook or content. It all depends on your external research and how you talk with other people, talking with professors, talking with all the years. Imperial Aero has multiple weighted deadlines every single week. Get used to days where you do nothing but work. So if you look at that picture on the top, that's me and my boys in the library at 5 a.m. working on the MATLAB coursework. If you get into year one, you'll understand what I'm talking about. You'll have a few of those days. Another thing that's rare about this course is the fact that you basically live in one room. On the left is an image of SCHEM 164, which is the lecture hall that you're going to use for all 4 years. And every single lecture, every single tutorial you have is going to be in this room. On the right is the kind of projects that we do. So Imperial Aero has some weird ideas for projects actually, where on the right, that is the first term project where we have to take apart a remote control car and then we have to rebuild it. And we have a few projects like that, which are quite hands-on, which are quite teamwork based. So it's not all just learning and course content and writing papers. I think one of the most important things that makes this course unique is the tutorials. They're delivered by all the years, teaching assistants, and they can range from, putting a question on the board, one of the harder questions on the board, and then these all the years walk around helping you get through it, or they can involve just working through homework questions that we were set. Another thing that's really good academically is the access to world-class professors. You're not going to have much of a chance mid-lecture to talk to a professor because about 50 people go to them every single time. But we have an online forum called EdSTEM where you can ask any questions anonymously, which I do a lot. And most importantly is the kind of community that you're around where everyone is really actually interested in aero. So people enjoy planes, F1, engineering, and rockets in their spare time as their hobby. And a lot of the people you'll meet are just trying to gatekeep content, keep it away from you, just to succeed in their own goals. So it's important to keep this in mind, which is why I'll end on saying this is the most competitive aero course on earth. It's also the most in-depth. It might be the hardest. So if you apply, you should want to apply because it's a very good course and I enjoy it. But just make sure you really want to do it before you click apply. Jazakallah.
Jazakallah, Faaris. That sounded very insightful. Just a quick note of questions. Feel free to pop them in the chat and then we'll get our panelists to answer them at the very end. And finally, I'm going to move on to mechanical engineering by Ateeb.
Assalamu alaikum, guys. My name is Ateeb, and yeah, I do mechanical engineering at Imperial. Yeah, so to get into Imperial, like everyone else has already said, you apply on UCAS. You pick Imperial as one of your 5 options, and then you have to do the ESAT test. So if there's 3 tests, there's 2 maths tests and 1 physics test. And then if you do well in the ESAT, you get called in for an online interview, which is about 25 to 30 minutes. Everything in the interview will like 50 to 60% of the interview will be about what you wrote in your personal statement or whatever they like. I think it's 3 questions now. Whatever you wrote for those 3 questions, it will mostly be about that personal statement that you wrote. So make sure you know that information like before you go in, you make sure you know it well, you can explain it to someone. Um, yeah, the offer that most people get on the website, on Imperial's website, it says the minimum offer A star, A star, A, but most people I've seen get 3 A star offer, and 2 A stars have to be in maths and physics. Yeah, sometimes you do get reduced off of A star, A star, A, or 1 A stars and 1 A star and 3 A's if you're doing 4 A levels. But yeah, mostly I've seen you get a 3 A star offer or 2 A stars, 2 A's offer. Yeah. So just a rough course overview. Not many people understand what mechanical engineering is. Even I didn't understand what mechanical engineering was when I went into it. But basically, it's basically studying how engines work and how to supply power to different things. It's not like you're not going to turn into Iron Man by doing this course. It's very like how to deliver power to different things. So the modules in mech eng can be split into 5 different groups. So you have the solids group, the control group, the thermofluids group, the maths group, and the practical group. So in solids, you do those are just the names of the modules that you do in first and second year. I think you do 9 modules in first year and then 10 modules in second year, and they all of their exams are in the summer. So materials, you is basically like the biology of mech. I call it the biology of mechanics because there's a lot of memorization, a lot of stuff that you just need to remember for the exam and just regurgitate it when they ask you questions. Stress analysis, so learning how beams bend and deform, just like deflections, stuff like that. Mechanics and dynamics, those are like movements of bodies and particles and how things move basically. I think they're very similar, but apparently they have different meanings. So in first year you do mechanics, in second year you do dynamics, so it like changes. In the control module, that's like it's not mechatronics. It sounds very fancy, but it's just electricity. So your circuit components, um, diodes, wires, resistors, capacitors, op amps, all that stuff. So you do that in first and second year as well, and then you move on to like control diagrams and control blocks and how to do like response diagrams and stuff like that. So thermofluids, that's probably the hardest group. So in first and second year, you do thermodynamics and fluid mechanics, and then in second year they also give you heat transfer as well. So fluid mechanics is how like fluids flow basically, like equations defining how they flow. Thermodynamics is more energy based, like studying how energy is transferred to and from objects and bodies, and heat transfer is transferring temperature between different components. So not specifically energy, but more temperature. And then in maths and computing, all the maths in the maths that you do in first year is pure, and then in second year it's all numerical methods. So um, I didn't understand anything until like a month before the exams, and then all the computing that you do in second year is all for the numerical methods. All the computing you do is for the maths module, and all the math stuff that you do is for the computing module, if that makes sense. The language that you get taught is Python, but I've found that you just have to teach it yourself. The lecturers aren't the most like approachable, if that makes sense. A lot of the content you'll be doing a lot of self-teaching or asking your friends for help or watching YouTube videos, stuff like that. And in the practical side of things, you have DMF, so design for manufacture and professional engineering skills. So design and manufacture, that's all your professional like workshop stuff. So if you go back 2 slides, one more. Yeah, so in that corner, that was my second year DMF design project. So we had to design a compressed gas powered car. We spent one term doing that. So if you see the axles for the wheels at the bottom, that was all designed in the workshop. That pink thing is 3D printed using acrylic. And yeah, but the more components, like I think a lot of that was manufactured in the workshop. Yeah. And then in yeah, so no, back one slide. Sorry. So yeah, in this corner, this is from this year's DMF and my project this year. So that's basically a finite element analysis, analyzing stresses in that component, which is it's a gimbal, it just controls directional movement and stuff. Yeah, and then the last module that you do in first and second year is called PEN, or professional engineering skills. I think every engineering degree has actually even medicine degree. every degree has some sort of module like professional engineering skills. You learn about like ethics and health and safety and stuff like that. So in that picture, that's CAGB 200. That's the main lecture theatre where you'll have um lectures if you pick to do mechanical engineering and get in. Yeah, it's quite a big. I think it's one of the biggest lecture theatres on campus. Yeah, and the mechanical engineering building is the main Imperial building, the one you see when you like when you walk in front of Imperial. You've seen pictures. That's the mechanical engineering building. Yeah. Yeah. Okay, so this is a bit of a overwhelming list of modules. So these are all your third and fourth year modules. So everything after the second year is completely optional. It's completely up to you. So how you design the course, how you want to uh, choose or make the courses, all entirely up to you. So in the left column is all third year modules, and then the two columns on the right are your fourth year modules. So you can see it's very broad as to what you can do. You have stuff like automotive design with motorsport, so like cars. Then you also have like learn C for microcontrollers, EDI, FEA, equality, diversity, and inclusion. So it's very broad as to what modules you can pick and what you want to pick. Um, and then in fourth year, it gets even broader. You can see that there's even modules from other degrees that you can do, like nuclear materials and optimization and sustainable electrical systems. It's very, very broad. So I think that's a bad thing personally. But if you still don't know what you want to do, then mechanical engineering, like I don't know what I wanted to do when I was applying. So I knew I wanted to go into engineering, but not specifically which one. So I picked mechanical engineering because it is the broadest thing. Like you can do the most with it, or like branch off into the most different things. Yeah. So a course overview. In the top, you can see a rough split of how you're taught. So, yeah, like I said, it's mostly independent study. So in first and second, it's 80% independent study. You have to do a lot of self-teaching and like YouTubing and Googling and asking around. In third year and fourth year, you do get a group project. In third year, you get a group project. In fourth year, you get a single individual project that you have to do, which counts towards your final degree. Even in first and second year, there's smaller projects, but not on the scale that's on third and fourth year. So, for example, in first year, we were designing a drivetrain for a printing press, and in second year, we were designing that compressed gas powered car that you saw in the first slide, and also in second year, we were designing a automatic coin flipper. So it does contribute to the degree, but not as much as the projects in third and fourth year. And for assessments, it's very exam heavy. So you can see in first and second year, in the bottom picture, it's a 75% exam split, and then in third and fourth year, it sort of like decreases the amount of the exams are weighted, but it's still quite large. Like also all your exams are in the summer, unless in third and fourth year you might have the one odd module where you have a January exam, but other than that, all your exams are in the summer. So for me, in first year, I had 9 exams in the summer. In second year, it went up to 10 because you get given another module, and yeah. Um, so another thing that you can do with Mecheng is you can apply to do a year placement, and then that gets added to your degree. So, for example, you can go to work in any of the F1 companies, or maybe like automotive company like McLaren or Toyota or Rolls-Royce. Rolls-Royce do airplane engines now; they don't do cars, yeah. Or you can even apply to do any like design, or basically anywhere engineering that you can get the admissions people, the admin people, they'll put it onto your degree and say, oh, this guy did a year placement, and then your degree will change from mechanical engineering to mechanical engineering with a year in industry, and that's still accredited by the accreditation people. Yeah. Another thing you can do is you can do your one of your years abroad in a different university. I think there's a list of different universities on the website you can go to, but I think you can go to like there's one in Australia, one in Switzerland, one in uh, Korea as well. I think I forgot the list, but there's a different universities. You can spend 1 year, one of your either your third or fourth year, in another university, and that gets added to your degree. So change from mechanical engineering to mechanical engineering with a year abroad. And the last change that you can have done to your degree is the nuclear stream. So if you go back one slide to the optional modules. So in the third year module, if you see okay, so it's very unclear, but in the third year modules, you have Introduction to Nuclear Engineering and Nuclear Chemical Engineering. So if you pick those two modules, and then you'll get put onto the nuclear pathway. So your degree will change to mechanical engineering with nuclear engineering. So if that's interesting for you, then you can look into doing that. Yeah. Yeah. So lastly, just something about mechanical engineering. It's very broad, like I've said. There's a lot of different things you can do with it. Um, it can be overwhelming, but everyone else is being overwhelmed as well. And there's a lot of imposter syndrome. I know there's a one person in the year below us. He designed an entire exoskeleton suit thing before he even got in. He wrote about it in his personal statement. A lot of people do mechanical engineering in their spare time, like Faaris said for aero, it's very similar for mechanical engineering. So if it can feel like you're like missing out or not doing enough or anything like that, or feelings like that. But the important thing to remember is just like focus on what you're doing, try to develop an interest, do what you're good at. So yeah, this picture, this is my third year project. We're designing a rocket to like launch into the space or something. I don't know where it's gonna go. But yeah, as for marking, I know for A levels and GCSEs, it's very clear where you get your marks from. You have the mark scheme, and the markers don't really change that much from that. But once you get to university, you'll realize that every lecturer is different. Everyone has a different style of marking. There's really no consistency of where you're going to get your marks from. Um, so don't be too disheartened. I know at like school people are getting 90s and 80s, so it's nothing unusual when you get to Imperial and start getting 60s and 50s in your marks. So it's very not unusual. Yeah.
Jazakallah Ateeb. So we're now going to move on to any questions. So feel free to put them in the chat. I'll start. I think Nabiha has asked, would engineering be a good choice if you like physics but dislike math?
I mean, I don't
Any?
mind jumping in.
Yeah.
Like, I'd say I'd say it wouldn't particularly be a good choice because maths is like the backbone of the course. So all of the modules that I've said, and I think many of my other colleagues have said, yes, they do sound like different things, but they all have that element of maths in it. So for civil engineering in particular, you learn pure maths for 2 years, and you might think you're done with maths, but you're really not. You use that to apply it for all the other stuff. So if you initially don't like the maths or don't engage with it, then you're going to have a difficult time engaging with all the other modules that they offer.
Yeah, I was speaking to someone like a few days ago or like last week or something, and he made me realize that when you're walking around Imperial, like, no one in Imperial doesn't have an A star in maths. So if you dislike maths, then I guess learn to like it or try to enjoy it. Find ways to enjoy it because if you wanted to go into STEM, then maths is a very important part of it.
Yeah, I'd just add on to that. Everything you're doing in A level is base stuff for engineering and uni. It's not that's the furthest you're going to go in. You're going to go in deeper to it, and you're going to use all the methods, matrices, vectors, differentials, integrals. They're all part of the real things, and they might be applied to aerodynamics or structures or thermodynamics, but they are used. So you need to have an appreciation for using these as tools.
Tahmid, anything to add?
No, not really. Everyone has hit the nail on the head. So yeah, you gotta like maths to actually enjoy engineering. Yeah, physics not enough by itself. So yeah.
Thank you. And a follow-up question. Do you think you could start liking maths, or would it have to be forced?
I think it really depends on what you would want to like, what you would do like by yourself. So I know a lot of people don't like maths because they don't understand it, and that could be down to like a number of things, like the teachers aren't good or they're not explaining it the right way. I think if you put if you put the time in, then and you start to like understand how the maths works, then it becomes, I wouldn't say easier, but it's like less hard, less difficult. And I think the more you understand like how the maths work, the more you start to become better at it, and like you start enjoying it more. A lot of people don't like maths because they think it's hard.
Yeah, I'll add on to that um math is really nice. It's not that the actual doing math and writing equations is fun. It's just nice because it's the only thing that really gets the correct answer. So to enjoy maths, you just need to be someone that likes seeing the process and satisfaction of this is the correct answer, this is the process, this is how it works. So to enjoy maths, the best tip is just get good at it. And if you get good, you will enjoy it probably because you're solving problems, you get the right answer, you feel happy, nice. That's it.
I have a little to add on that. I'm not one of the presenters for this webinar, but I personally do computing. Now, out of all of the engineering courses, if you include computing in that, we probably do the least amount of maths. Though we have to do lots of proof-based work.
Great, thank you for your add-on, Kamal. Another question, can you apply for multiple types of engineering in Imperial, or can you only apply for one?
Personally, I know people on my course who've applied for multiple degrees, like engineering degrees at Imperial, but I don't know if it's particular because they were international students, so I don't know how that varies if you are home students, but I'd assume that you can. But just be like, keep in mind that Imperial is very difficult, so having two Imperial degrees might narrow your chance of getting into a university.
Yeah, from what I know, I think you can apply to multiple types of engineering. So if you want to apply to multiple types, then yeah, go ahead, honestly.
I've got a bit to add to that. I personally applied for maths and I applied for computing as separate options. And I got rejected from maths, but I got accepted for computing. So if you want to apply for multiple courses from Imperial, double check that they're from different departments. If they're from the same department, they might consider you to be the same choice. For example, I think there's mechanical engineering with international study, and there's mechanical engineering just with home study. So don't apply to both of those because they're considered in the same pool of applicants.
Right, the next question is more focused towards Faaris. For aerospace engineering, how much do the entrance exams count towards getting accepted? So what is the most important factor to getting into the course?
I think the most important factor is doing all right in everything and not being terrible at one of them. So, like I said, there was a 30 question test that I had to do, and it was negative marked. So I don't know if it's the same nowadays, but it was the MAT, and I only answered 8 of them. So that is shocking, someone that was getting 90s and 100s, A stars in maths. It was a purely maths-based exam, and I only answered 8 of 30. But I mean, I still got in. Um, I think you need to be exceptional in one kind of thing. So I would say my personal statement was there because I fully understood how to write it. I think also my interview um, carried a lot of my passion for aeronautical engineering clearly. So it's more about just not being terrible at any of them and being pretty good at some. But I wouldn't say any are more important than the other. Just don't flop at one of them.
Perfect. And another follow-up question for yourself is how many years is the aerospace degree and how often do you get to do work in the labs?
So the aerospace degree is 4 years. It's the shortest aeronautical MEng in Europe. Normally they're supposed to be 5 years, but this is 4 just because it's so condensed. Um, in terms of how long it might take, you're allowed to take 6 years to complete this 4-year degree. You can add an extra year for going abroad or for going into industry in your 3rd year. And how often do you work in the labs? You will have about 4 to 5 labs per term. And these are experiments that they tell you to do with a very specific handout, and you usually have to write a report on it. And in my experience, they're probably the deadest part because you want to learn the content and just get the exams revision done. But then you have to waste time on writing up or just doing labs and doing orals at the end. So, I wouldn't really want to work in the labs if I had the choice, to be honest. I mean, it's good to see it in practice, but it feels like a waste of time.
Thank you. And do GCSEs matter a lot? Got a 6 in maths and do the A level, but my overall GCSEs were 99988888766. I can elaborate on subjects if that would be helpful.
Well, I mean that I know that they look at your GCSEs, but they look at them in a contextual way. So like let's say that you were from like a disadvantaged background or there was a circumstance that led you to get those grades, they would consider that. But I'm not too sure about like if that isn't the case.
And do you think it's possible to get far in engineering if your passion for it isn't that strong?
I'd like to answer that one because I feel the very same way, where um, my passion for engineering isn't that high. What I really want to do if I had all the time and it wasn't academia would be football. So what you see is that the people that have passion for it and they spend their time on it all day, I know guys that come in at 8 a.m. and leave at 8 p.m. and they find it fun and that's their lifestyle. They're going to do extremely well. They're going to be Dean's List. I don't really have a passion for it, but I treat it as school. So, I get the assignments done, I work on it as hard as I can, but it's not something I really enjoy. And what that means is that the process is not as nice, but if you just treat it as school, you can still get a decent 2-1, maybe a first, which is what I'm predicted at the moment. But if you're not reading outsides and using it in your own free time, you're going to struggle, but it's still doable.
Yeah. Also, um, I don't know about for the other engineerings, but especially mechanical engineering, people go into mechanical engineering thinking they love engineering, and they realize halfway through the degree that it's not what they thought it was. Um, like me, I thought it would be like proper like designing stuff and making things. I would spend a lot of time in the workshop and things like that, but it just turned out to be energy and energy systems and things like that. So when most people realize that, they look into other options and they end up going into other fields like finance or consulting. It might sound like a bad option right now for you guys, but it genuinely becomes a thing that you have to look at when you get to the point where you don't want to do engineering. I will say that the engineering degree itself is looked at favorably to employers in other fields because it shows that you have an analytical mind, you understand how to solve problems, um, and stuff like that. So just because you don't have a passion for engineering, like Faris said, just treat it like school and you'll be fine. Sure.
Perfect. Thank you. I think that's all the questions we've got. Oh, never mind. Um, Another aerospace question. What are the most common A-level grades people get in aerospace have got other than 4 A stars?
Um, your other is gonna, unless maybe you get contextual, it will be 4 A stars, but it's more about the fact that most people miss it, so they just let other people in. So I've seen people that had 4 A star offers, but then they got in with 2 A stars and 2 A's, or 3 A stars even. And it's possible, for the most common grade you're gonna see within your course if you study aero is 4 A stars. Everyone pretty much has it. And it's always the same four, which is physics, maths, further maths, and chemistry, or computer science.
And Yasin, this might relate to you as well. Is a computing degree more beneficial or an engineering one in terms of job prospects?
Oh, well, that's going to depend on what you want to do. I think in terms of like pure salary, computing is the highest overall. But if you want to work on making things and the kind of things that other kinds of engineering do, you want to go into one of those instead.
What's the job market and prospects like for engineering, and which engineering discipline do you recommend?
Um, so for the job market, it's very bad, and especially in the UK. No one wants anyone. And it's all like, especially because COVID happens, companies have started realizing they can just hire from within the same company. So they just recycle the same people. So it's very hard to break in unless you know people within the company or you go out and do networking. For engineering. And like, I don't know if where in the UK that you live, but you probably have noticed that. Um, the UK is a very finance-based country now. So a lot of the GDP and like the economy is based on finance. Not that much manufacturing goes on, not that much designing. All this stuff happens in like America or Germany or um, even like consulting stuff happens in the Middle East. Engineering happens in Japan, China. So maybe if you want to go to a different country or um, start looking into stuff like that, then maybe the job market might be better. But in the UK itself, I think that the computing job market is much bigger than the engineering job market. Yeah.
Right, I'm going to move on to the two last questions. Well, number one, what if you don't do full A levels? Can you get into aerospace still?
Imperial Aero is probably the best degree for aero in the planet. Maybe MIT is better. So they're looking for the best people. I mean, I know a guy that he got 3-star offer, so it's possible if you do really well and everything else. But if you want to get into this course, just make sure you do everything you can to get in. And 4 A levels is really what you want to be getting. While it's possible that you can get in with 3, I would very strongly recommend if this is the course you want to go into, you take 4.
And final question, what is everyone planning on doing after their degree if the job market isn't great?
I can go ahead and say. So, in terms of like the other engineering, civil engineering actually has some good, like, it's very much simpler to get a job after graduation. The salaries are a bit lower, but I feel like if you go into a specific like niche, such as like the fluid mechanics for like built environment or structural engineering, that's where you can expect a higher salary as opposed to just general civil engineering. For me personally, I'd like to get into structural engineering, maybe the effect of like designing like earthquake proof buildings or looking at like tunneling.
Perfect. Thank you. Jazakallah khair to our panelists today. If you guys do have any more questions, feel free to drop us a DM on Instagram or LinkedIn. Guys, if you want to leave your LinkedIns, feel free to drop them in the chat as well. Just a quick thing. Quite a lot of you guys spoke about your personal statements. One thing that you might want to add is our STEM Day, which is coming up on the 19th of Feb, and it is very aero engineering focused. I think Yasin will drop that in the chat as well, so feel free to apply to that as well. And yeah, that's all from me. Anyone have anything else to add, or can we wrap this up? Okay, I see LinkedIn's being dropped. Yeah. Perfect. Thank you, guys. I'm going to end the meeting here now.
Jazakallah for the opportunity.
Assalamualaikum.
Assalamu alaikum.
Assalamu alaikum.